Thank you. Good evening. Thank you all for coming. My name is Sadie Alley Ferreira. I'm the Power Engineering Technology Program Coordinator. Tonight is our second session of presentations for the PET students who have done their co-ops. Tonight we'll have one student who has done their CO300, and he will be focusing on a little bit about his plant and then his technical analysis. And the rest of the students will be talking about the plants that they interned at, as well as the safety culture of their plant. So I won't be having questions and answers in between each of the presentations because we have 21 to do tonight. So we're going to hold questions until the end, and I encourage you to get together and ask questions individually. So thank you, and our first is Cooper Peterson.
Good evening. My name is Cooper Peterson, and I'm a senior in the Power Engineering Technology program. I spent this past summer in Rumford, Maine at Nine Dragons Paper Company working on the recovery boiler. Rumford's recovery boiler is 12 stories and can produce up to 680,000 pounds an hour of 1,300 pound steam. For those of you who don't know what a recovery boiler is, I will briefly explain it. The main purpose of a recovery boiler is to recover the inorganic chemicals from black liquor that be reused in the paper making process. This is done by spraying black liquor into the boiler and using it as fuel. The organic compounds burn off and release heat, in turn generating steam, while the inorganic compounds and chemicals fall to the bottom of the boiler and flow out as smelt. This makes a recovery boiler a good way for paper mills to offset costs. So part of our summer project was to do a technical analysis on something we thought we could improve in the plant. And for CO200 students that haven't done a technical analysis yet, it's basically just an engineering-based evaluation of a problem and a proposal to correct it. You can do it in any form you want, but I chose to do an economic analysis because that fit my idea best. So after a few weeks of working, it became somewhat obvious to me what I could do for my technical analysis. I found myself spending a lot of time in the smelt pit. The smelt pit is where the smelt flows out of the boiler and goes into the dissolving tank. The smelt spouts are supposed to be rotted out every 2 hours, but most days I found myself having to go down there a lot more. The pit is a very dangerous area, and during orientation I was told that the pit was the cause for the most reported injuries in the mill and is regarded as the most dangerous spot. This is mostly due to the unpredictable nature of the smelt and it being roughly 1,600 degrees. And that's an example of the spouts there. So I began researching possible solutions to the problem, and the best thing I found was a smelt spout cleaning robot. That's shown there in figure 3. There's a variety of different options, but I found that Valmet made the best one. I then contacted Valmet and they provided me with details and price options. I then estimated the average time I spent as an operator in the pit each shift, and I used that in my in my technical analysis. I tried to get information about safety incidents related to the pit and the spouts, but I wasn't able to get that information for whatever reason. Without the safety factor, I thought my analysis wasn't really going to be that good, but it just so happened as part of the upgrade, it required an upgraded steam shatter spray. And so recovery uses the most steam out of the whole mill, roughly 150,000 pounds an hour. So the upgrade would save a lot of steam, and when I factored the steam savings into my economic analysis, it worked out pretty good. So after all that, the price of the robot was really high. So when I first brought it up to the management, they weren't very pleased with it. But once I found out about the steam shatter spray upgrade, they were really pleased to see the steam savings and the amount of money it could save the plant. And because of that, I think the analysis worked out pretty good. And Rumford was overall a really good co-op, and I would recommend it to any students that are looking to go there. That's all I got.
So my name's Benjamin Elliott, and I worked at ND Paper Old Town mill this summer. And the mill produces about 15 megawatts a year, and we only sell 2 or 3 back to the grid. We just basically produce power to run the mill. The plant's capacity is about 700 pounds per hour of steam, and the plant would normally run unless we had a blackout or a planned shutdown, like the month-long outage work that is coming up. The plant burned natural gas, black liquor, and wood chips. And the plant safety, so every new hire would have to go through trainings before they could even start work. And these trainings would include confined space, lockout, tagout, fall protection and prevention, hot work safety, line break safety. As well, the mill would have weekly safety meetings per department. So they would have our safety manager come in and talk for about an hour of something that is important for safety that week. And the mill also had a book called 360 Analysis, and before you did a job, you had to fill out a 360 for every job you did that day. It's peaking really fast. So, there we are. So I was classified as a power engineer intern working at ND Paper, and I would follow around the recovery boiler field operator on their daily tasks, which included boiler cleanings, boiler walkdowns, green liquor tests, and any other tasks the lead operator told us to do. During my time at ND Paper, I experienced boiler shutdowns due to an economizer leak and for other systems being shut down because the recovery boiler is connected to so many systems. If one of those goes down, the recovery boiler has to shut down as well. And I learned about other systems like the craft liquor cycle, which is used to produce pulp, paper. It's basically how you change black liquor to green liquor to white liquor. I learned plant operations, plant maintenance, recovery boiler operations, and so Old Town Paper Mill is not actually producing any paper anymore. They're strictly producing pulp, and that is because producing paper isn't really cost effective anymore. So they produce the pulp and send it straight to China to make boxes. Oh, and in conclusion, I worked at ND Paper Pulp Mill, and it is a very well-run place. I would recommend it to any sophomores starting their co-op what is it called? Search, and everyone there was very helpful, and I learned a lot of information that I will always have the rest of my career. Yeah. I got nothing else to say.
Good evening. My name is Colby Hurd, and I did my co-op at Penobscot Energy Recovery Company. It's in Orrington, Maine. So this plant produces 25.3 megawatts, and that is when they're running both of their boilers. But typically they were only running one because they didn't have enough RDF to actually feed the second one. It produces a maximum of 133,400 pounds of steam per hour. And like I said before, they use refuse-derived fuel, which is basically ground trash. It is a baseload plant, so that means they're running 24/7 every day of the year, as long as there's no problems. And in the picture, you can see that is their steam turbine generator unit. So safety at PERC was a very big priority to them. In the picture, you can see a couple examples of the most common safety equipment we had to use throughout the day. A hard hat, safety glasses, and gloves were mandatory for all jobs. That also includes steel-toe boots around the entire plant, and depending on the area, you had to wear either hearing protection, or there were some times where you had to wear like a respirator when you're working with ash. At the beginning of everyone's employment there, they must take safety training with their safety advisor there, and that typically takes 2 days of around 5 or 6 hours each day. There's also a yearly fire safety program where everyone that is employed there must go and prove that they can use a fire extinguisher or anything of the sorts in case there is a fire at the plant. There are also yearly health checkups to make sure that you're not going through hearing loss or sight loss or anything along those lines. Like I said, proper PPE must always be worn around the plant. And lockout tagout was another big hitter there. They wanted to make sure that if you're working with anything, you shut it down, make sure there's no way of getting power to it so that there isn't any chance of an incident happening that you didn't want to happen. So my work experience, I operate as a B operator. This was working around the boiler house, and I also did do some work in like the cooling tower area, but most of it was around the boiler house. I worked with most equipment in both of them a little bit or quite often, such as the feeders. I also had to fix quite a bit of issues, especially when you're on night shift. They don't have a maintenance crew there, so if something arises, you have to fix it as well as you can until maintenance can come. I help keep the boiler running as efficiently as possible, so if the A operator who was handling controls needed like some extra steam or something, I would go and turn the valves that they told me to make sure that we're going as efficiently as possible. And through all this, I learned pretty well how most of that plant runs. There wasn't much that I wasn't able to touch, so I handled the ash systems as well as making sure the boilers were running efficiently and making sure that conveyors were bringing the fuel where it needed to be and nothing was getting stuck or broken. And I also learned how to carry out most basic maintenance on all this equipment as well. With running trash, there's a lot of buildup and causes for a lot of issues over time. So you have to touch up and make sure you're keeping on top of things before everything breaks down and you can't actually produce power. In conclusion, PERC, I believe, was a great experience for me to have for a first internship. I gained a lot of great experience that most people might not if they're working in a plant that runs perfectly and they don't have to actually go and work on stuff. I touched most equipment in that plant, so if something happens, I have that little bit of extra knowledge on how to fix it in the best way that I can. I also gained a great deal on how steam-driven turbines work. Here you touch on it some, but getting out in the field and actually seeing it does a wonder. Being able to see the actual blades on the turbine turning. I learned a lot mechanically as well, working with all the equipment throughout the day, and used the decades of experience that the other operators there had to help boost my knowledge. Thank you.
Hi, I'm Patrick. Oh, shoot. I'm Patrick Miller. I spent my CO200 field experience at Jackson Laboratory in Bar Harbor, Maine. So Jackson Laboratory is a lab mouse developer and distributor, and they're a biomedical research institution as well. And their research is focused in cancer research, immunology, developmental biology, and neurobiology. And they sell an average of 3 million mice per year to research facilities. So I worked in the utility plant, and the utility plant provides steam and chilled water to processes in the lab. So the steam and chilled water is used for the air handlers and keeping the mice at a constant 72 degrees all year round. The steam is also used for sanitation and sterilization, that everything that touches the mice and is in contact with the mice. So we have 7 total boilers. We have a pellet boiler that's a Babcock and Wilcox, and that's a 1,200 horsepower pellet boiler. And then we have 2 packaged Cleaverbrook boilers that are 800 horsepower fire tube boilers that burn fuel oil and liquid propane, as well as 4 Cleaverbrooks 500 horsepower fuel oil boilers. And that's for a combined 140,000 pounds per hour of 85-pound steam per process. So there's also 4 Caterpillar diesel generators that put out 6.25 megawatts, and those are used for emergency generation, real-time demand response, and load reduction or peak shaving, which is done in peak seasons throughout the year. There's also 8 chillers with a combined 8,000 tons of cooling capacity, creating chilled water. So the safety culture at Jax was pretty serious. Much like the industry standard, there was a first safety training week where we spent a week just going over lockout, tagout, fall protection, personal protective equipment, confined spaces, hot work permits, all that stuff. But there was also some training related to the laboratory setting. So that was like biohazards, nuclear stuff, because there is nuclear products on the lab. So it was a lot of training regarding if we had to go into the laboratory and fix some of our steam piping that was out on campus. So from my experience, so we did daily rounds every 2 hours on the chillers, boilers, and generators. And there was a lot of general operations on the pellet boiler. Pellet boiler is a biomass plant that the fuel is always changing. So it was difficult to keep the curves exactly right, and we'd have to constantly change the mill curves and the running parameters of the burners on the pellet boiler. There's also an automation system that lets us choose which boiler we want to put in liter lag. So depending on the steam load that was coming up for that day, we would stage up different boilers depending on what was in an outage or what was available. And the same with the chillers. Those would all stage on automatically depending on the chiller load, but we would adjust those to which chiller we wanted to run. We also had a single stage impulse turbine. It was a Dresser Rand. It was pretty small, and it would only run at certain steam loads. So when we had high steam loads, we could run the steam turbine as our reducing station. But when the steam load would drop off during lunchtime or during the nighttime, we would lose the turbine. So we took that down for an outage to try to put a new nozzle block in it so that we could run it at lower steam loads as well. So for maintenance, I did a lot of work on pumps with bearings and seals. We did alignments on motors and bearings on motors. The mills always needed new hammers and screens to keep the powder consistent. And the bag house had a leak at one point. So we worked on mostly surrounding the pellet boiler because it is the most finicky boiler. The Cleaverbrooks don't run as much, so they kind of sit there. But I did basic maintenance on pretty much all the equipment that had issues. I also got to see outage season there this summer. So we had 4 out of our 7 boilers come down while I was there, and I got to do the lockouts and take apart the whole boiler and follow the inspection around. So that was a pretty strong learning experience. In conclusion, Jackson Laboratory was a great learning environment. I was working with pretty much all Maine Maritime grads, and it was just a very, they taught me anything I wanted to know, even if it wasn't related to boilers. So it was a great experience, and I would highly recommend looking into Jax for future employment or co-op opportunities. Thank you.
Hi, so my name's Ryan Paradise, and I did my CO200 at Penobscot Energy Recovery Company in Orrington, Maine. And is it working? Hold on. There it goes. So PERC is a baseload plant, and they're capable of producing 25.3 megawatts. And they do this by using 2 Riley Stoker boilers that each produce 133,400 pounds of steam per hour. They burn RDF, which is refused derived fuel, and that's produced from municipal solid waste, which is ground up in the Terminator, which you can see in the background, and processed. And the plant operates 24/7, 365. So safety at PERC is always a big deal, and every new hire has to go through a safety protocol, and it's a 2-day training course where you learn a lot about lockout, tagout, and other procedures that they use at the plant. And you have to wear proper PPE, which, as you can see, it has hard hat, safety glasses, gloves, and steel-toe boots. And you also had to wear hearing protection in certain areas. And if you went into a confined space, you had to do a confined space entry permit and wear a respirator depending on where it was. And another big thing about working safely is you got to work ethically, because you can't mess up, because you might hurt yourself or other coworkers. So for work experiences, I was a boiler operator, which is they physically operate the boiler in any means. And I worked in the cooling tower, the atomizer deck, the boiler house, and Slaker house. And in the cooling tower, we didn't do much down there. It was more controlling the fuel pumps and checking water levels and chemistry tests and stuff like that. The Slaker house is where the lime silo gets mixed with water to create a slurry, which gets sent up to the atomizer deck, and the atomizer deck processes it and controls emissions using that in the bag house. And in the boiler house, our main job was to work on the feeder deck, where the RDF would get wrapped around the screws, and we would have to clear it off to feed the boiler with RDF. In conclusion, I thought it was a great learning experience. Everybody there was very good. There was a lot to learn. A lot of stuff went wrong, so there was a lot of learning experiences. Everybody there was very helpful. There was MMA grads there, and they knew what was going on and what we were going through, so they were very helpful and understanding on our knowledge. And the location was great. It was right in central Maine, so you didn't have to travel too far depending on where you were. Everything around there was nice. And thank you.
Gonna work? Or? There we go. Okay, good evening. My name's Ethan Snowman. I'm a senior in the Power Engineering Technology program, and I completed my CO200 industrial field experience at Penobscot Energy Recovery Company, located in Orrington, Maine. So, a little about PERC. It's a waste and energy facility. They take MSW, or municipal solid waste from outside vendors and grind it up with terminators or grinders, as they like to call them, and that turns it to refuse-derived fuel. The plant was equipped with 2 Riley Stoker boilers capable of producing 133,000 pounds of steam per hour. And these boilers fed the 15-stage steam turbine generator unit, which was one solid unit, manufactured by General Electric. And that turbine was capable of producing 25.5 megawatts of power, max capacity. So the safety at PERC, orientation was for the first 2 days. They talked about slips, trips, and falls, hot work, lockout, tagout, just about all your PPE, stuff like that. And like I said, that lasted about the first 2 days. Obviously, their safety is one of the #1 priorities they do. Safety is a huge aspect of working there, especially because you're working with heavy-duty equipment. Everything, a lot of hot things. It's a boiler, so you are given uniforms. It's a trash burning plant, so you never know what you're going to come home with. You don't want to come home with anything. Hypodermic needles, obviously, that's a big thing. But basic PPE, besides the uniforms, safety glasses, hard hats, gloves, steel-toed boots. They were giving us a lock for lockout, tagout with your name on it. We had radios, just so everywhere you had communication, just about everywhere you were in the plant. And like I said, lockout, tagout, confined space entry permits, hot work permits, environmental air quality tests were all frequently used at PERC. As you can see in the picture here, this is me in the steam drum. So I had to do an air quality test before I could enter that, along with a confined space permit. And just a little fun fact, that top picture there is what they like to call moon rocks. It's basically just a bunch of trash mixed with latex. We used to spray latex for a company into the furnace of the boiler. So that's what it forms. So working with heavy-duty equipment is kind of essential. We'd have to open up the boiler front, and take a big old jackhammer to it. And it's loud, heavy-duty, easily get injured. So my job at Penobscot Energy Recovery Company is I was a boiler operator, or a B-op, as they like to call them. So basically what we would do is, depending on what shift you were on day shift, you would do what they call the smooth log, which you go over all equipment, make sure everything's running fine, temperatures, pressures, vacuums, things like that. Night shift, you would go and do your midnight log, which is you would take fuel readings, look at the generators, stuff like that, see what you're doing with those. Water tests, chemistry, we'd take water from the cooling tower, hot well, and the feed water heaters. Test that water for oxygen scavengers and phosphate. My other duties were I would perform basic maintenance. I'd work with valves, pumps, conveyors, and the atomizers. I'd work in the bag house. The bag house seems to get clogged up quite a bit. So other than that, you'd always also shovel grit. You're there to work. They really do put you to work when you're there. I'd also maintain equipment like the feeders, ash drags, atomizers, conveyors, lime silo, and the bag house. So in conclusion, it was overall a great learning experience. I learned a lot. The people there, your coworkers, are great. Anything you wanted to know, they would tell you. So if you have any questions, you shouldn't be afraid to ask. That's what I got most of my learning experiences actually out of them. So they weren't afraid to show me around. I would recommend this plant to CO200 students. If you are looking to really learn, this is where I would go. It's a great place, great people, and overall great learning experience for anybody. Thank you.
Good evening, everybody, and thank you all for your attention. My name is Michael Perot, and this evening I'll be presenting on my CO200 co-op, which I completed at Re-Energy Stratton. So Re-Energy Stratton, which is located in the small village of Stratton, Maine, nearby Sugarloaf Mountain, is a baseload power plant which burns a primarily wood-based biomass fuel inside of its single Stoker-style boiler, which supplies roughly 400,000 pounds of 1465 psi 950 degree Fahrenheit steam to a 48 megawatt Mitsubishi steam turbine generator unit. This plant runs, like I said, it's a baseload plant, so it runs 24/7, 365, with 2 annual outages planned in the spring and the fall. Pivoting over to safety, I'm sure there are some of you that can relate to this when I say the very first thing I did on my first day at Re-Energy Stratton was read through about 5 inches worth of safety manual, which took me a good few hours to do. So I learned very quickly that safety was very important at Re-Energy Stratton. Cultivating a strong safety culture and, in general, a safety-conscious mindset in all of its operators was obviously very important to a plant like Re-Energy Stratton. And this was reflected and exemplified in all the operators that I had the pleasure of working with over the summer, especially when it comes to preventative maintenance on all the equipment as well as rounds keeping. Rounds were conducted every 6 hours on every piece of major equipment at the plant, and I was lucky enough to be a part of every single type of round sheet there was at the plant. As you can see here in this picture, that is a bucket filled with many, many locks with many tags on them. Lockout tagout is a huge piece of daily safety culture at the plant, and they were very quick to teach me about how to do it correctly. Throughout my co-op at Re-Energy Stratton, I was fortunate enough to be part of numerous jobs which required things like confined space entry, as well as hot work and working above the ground, requiring some rigging. Among many other kinds of dangerous work, of course. It is a power plant. If it weren't for the emphasis on safety by all of the employees at Re-Energy Stratton, who knows how any one of the hundreds of jobs that we completed over the summer could have gone wrong. So my time at Re-Energy Stratton was spent mostly doing 2 major things. The first simply being contributing to the safe and successful operation day to day. The second was actually completing a training program assigned to me by the regional director, which was basically a program which had the goal of qualifying me to apply for the plant's auxiliary operator position upon completion of my co-op. The auxiliary operator packet consisted of mainly tracing and drawing every major system at the plant, which I'm sure you can imagine was quite a bit of work, but it was well worth it. I learned a lot about, on the most basic level, just how to make good drawings in Microsoft Visio. You learn very quickly when you need to do about 9 drawings to make some really good drawings. But I also learned throughout trying to complete that whole training program what the day-to-day life looks like for an auxiliary operator at the plant when it comes to things like rounds keeping, general supporting for the control room operators, which are sitting at the DCS for their shift, going out and removing plugs in the different chutes around the plant, and as well as just performing preventative maintenance. All 4 of the photos that you can see on the screen here were taken by myself during the plant's spring outage, which I was fortunate enough to be a part of during my 2nd week at the plant. That experience for me did wonders, supporting and really solidifying everything that I've been learning in the classroom here at Maine Maritime. For my work experience, I learned how to perform preventative maintenance on every major system at the plant, as well as the importance of keeping accurate and timely rounds for all of those major systems. Regarding the logistical side of things, the regional manager who interviewed me, as well as the human resources assistant at the plant, were extremely helpful during the reception process, as well as throughout my co-op and leaving. The pay was competitive. I worked a sort of a random shift. It was very flexible. I worked for a few weeks a 4/10s kind of schedule. For about a month or so, I worked a 4-week rotating shift of blocks of 12-hour shifts. And during outage, of course, it was all hands on deck, 2 weeks straight of 12-hour shifts so that we could get everything done as fast as possible. The plant was also generous enough to assist with my relocation and housing nearby the plant. I only had about a 2-minute commute to work every day, which was very nice. So to summarize, my experience at Re-Energy Stratton was extremely positive, and I think it was very successful. As I said earlier during my discussion on safety, the operators at the plant definitely instilled in me a sense of pride in safety and attention to detail that I'll be sure to carry on throughout the rest of my career. I would absolutely recommend this plant to anybody that's considering it, whether it be for CO200, 300, or just a career after you're done at MMA here. The staff is full of Maine Maritime alumni, as well as the regional manager who reached out to me and interviewed me for the position. So of course they know what it's like to be going through this process, and they are there to support you and make sure that you learn everything that you need in order to be an effective worker in this industry. If you do, however, choose to work here, just be prepared for all of that extra work for that auxiliary operator training packet, because it is a doozy. And make sure that you can make some excellent system drawings in Microsoft Visio. That concludes my presentation. Thank you.
Hello, good evening. My name is Bennett Dunstan. I was a student in CO200 this summer, and I spent my time working at Rumford Power, located in Rumford, Maine, owned by Cogentrix. So our plant was a one-on-one combined cycle plant. It had a GE 7FA03 gas turbine, along with a GE A10 steam turbine, which ran off of our Hersig that produced about 1 million pounds of steam per hour. Our plant produced 265 megawatts peak load, and our only fuel source was natural gas. And we only operate typically during peak season. Once in a while they'll run during the winter, but it's not very frequent. And we start up every morning and shut down every night. So while I was there, we had about 42 cycles. So quite a lot. Safety was a huge part of the culture at Rumford Power. Just like many before me have stated, my first almost week was spent going over safety, you know, what to do in case of a bomb threat, blackout, all different types of procedures that were mandatory for all workers to know. Of course, you know, hard hat, safety, glasses, gloves, fire protectant, clothes at all time, were all a big part of my first week there. We kind of have a 3-phase system when it comes to doing any job on site, and of course that includes lockout, tagout, just like any plant you're going to go to, and you have other things like confined space entry. But on top of that, we have a work authorization form in which any job on site that is going to be done, does not matter how simple or how complex it is, a WAF as we call it, has to be filled out and signed by the A operator working that day on top of a JSA and on top of a lotto. So you kind of have 3 forms of certification for every single job, and it just really helps keep things straight, and everything's logged through the control room, despite whether it's contractors or fellow workers on site. We had a little slogan that we all went by every day, and that was no regrets. You know, basic form, don't have any regrets each day while you're working. You know, put your hard hat on. You know, don't go home injured, regretting, you know, not doing something simple. And each letter stands for a little something that the plant wanted you to think about while you're at work. I'll leave it up there a second if you want to read it, but I'm not going to go through the whole thing for time reasons. So my experience at Rumford Power, I was hired as an operations and maintenance technician. Of course, slap intern on at the end of that, but because of circumstances, we had 4 B-ops whom were in their first job and landside or working as an operator. So our plant requires everybody to be B-op and A-op trained, so they were working towards their A-op training because they were new. So I got to sit in as the B-op almost every single day. I got to do 18 startups and give them the opportunity to sit in as the A-op while I ran the Mark V, which was our control system for both our turbines. And
On top of that, you know, I got to do the typical plant rounds, plant normalization after startup, maintenance, got to work on just about every bit of equipment in the plant. Got to help out with root cause analysis a few times. We had a few steam leaks, so I got to get involved with some of the management and help them kind of figure out where the leaks are coming from, you know, just kind of basic things, but got to be a part of that. So in conclusion, overall, I thought the co-op was a great experience. They kept me very involved in everything. I even had opportunities to learn about the economics side of things, learning about the financials when it came to creating the plant budget and things like that, and just daily call the plant. Obviously, I got time working with the operators, got time working with the maintenance crew, and you know, out of 16 employees, 14 of them are MMA grads, so very understanding of all my questions, and you know, really helped me out every chance they could, very calm with me, and just taught me a lot. So I personally would highly recommend this to anyone who's looking to work in a combined cycle plant, because it's, you know, a large portion of our power production is combined cycle, and they're huge power producers. Great experience when learning about steam turbines, gas turbines. We take classes here, so it's a great opportunity to look at things like that in person, and the guys here are more than happy to get you involved in anything you want. Hours are flexible. They called me in 2 a.m., 3 a.m. for startups and shutdowns just to see, pay you for all of it, as much overtime as you want. So great experience, and I would highly recommend it to any students who are coming up to do CO200 next year. Thank you.
Hello, everybody. My name is Dylan Hiltz, and for my CO200 this summer, I worked at Assured Solar Energy in North Yarmouth, Maine. So, Assured Solar Energy is located in North Yarmouth, Maine. It's a solar design and installation company. They provide grid-tied and off-grid systems, which means houses or companies tied to the grid or on an island offshore. We do residential, commercial, and agricultural jobs, and we do them all over central and southern Maine. So, sort of a company service description. We designed and installed, or I designed and installed grid-tied and off-grid systems. I was able to use a software that the company used to design systems, as well as get on rooftops or out in the field and work on ground mounts. We installed any size systems ranging from only a kilowatt to over 50 kW systems, really large companies. The ones you see here, the top photo is at Maine Beer Company in Falmouth. I don't remember the kW rating for that, but it is huge. And the bottom picture is in the crawl space of a pediatric dentistry in Brunswick that I worked on. That was 111 panels. And we also provide a full range of installations. So we have rooftop installations, ground mounts, and trackers, which are large mounts that are motor actuated that follow the sun throughout the day. So for company safety, my boss always told me that they're never going to make me do something unsafe, and you never have to do anything if you don't feel safe. So we would always use fall protection. So you see a picture of me right there on a roof with a harness on. We also had pitch hoppers, which were like these foam landings you could use on a roof that would stick there to stand on. For PPE, I always used safety glasses while doing electrical work, while using a bandsaw and metal. I also used hearing protection for that. And you weren't required to wear any type of shoes, but the best would be hiking shoes or some shoes with good traction so you could stand on roofs well. Because at the near the end of the summer, my shoes started to wear out, and it was very tough for me to stand on metal roofs. And finally, every installer at Assured Solar Energy was required to take the OSHA 10 construction safety course, which is a 10-hour online safety course that details construction safety ideas and jobs that are provided by OSHA and OSHA regulated. So for my work experiences, I designed systems, as you can see from the top picture. I used a software called Aurora, and we were able to design as many designs as we wanted. I helped them speed up the processes because we were backed up several months and with jobs. And I got to do electrical work as well. I did a lot of DC side electrical work on the solar systems, as well as some AC. I got to help wire inverters, and I wired optimizers directly to the solar panels. Other stuff I did some boat work. So since we provided off-grid installations, we had to use our company boats to get to the islands. So I helped work on a lot of boats, and I redid the steering and a Grady White, basically all by myself. I got a little bit of help, but that was an interesting experience. But overall, I had a ton of fun this summer. It was super laid back, small company, only about 13 employees. So we worked hard. We got all the jobs done. We got ice cream a lot of the times when we finished jobs. It was great. I definitely recommend it if you guys are looking to go into the solar industry. And yeah, thank you.
All right, Re-Energy's back. This time, it's Re-Energy Livermore Falls, which is basically the ugly stepchild of the Stratton plant, not gonna lie. But my name is Logan Hiltz. For my co-op experience, my CO200 experience this summer, I worked at Re-Energy Livermore Falls, located in Livermore Falls, Maine. So this plant is a 39.6 megawatt output plant. It is a General Electric turbine generator setup. It generates roughly 334,000 pounds of steam per hour, but it does depend on the fuel being burned, the type of biomass fuel. Usually it would be wood chips, but we also burn demolition wood a lot, and bark as well. It is a baseload plant. It runs every day of the year with the exception of 2 shutdowns, which are usually about 1 or 2 weeks. When I first started working, I was working during the spring shutdown. And when I arrived at this plant for my CO200 experience, I had to take a harassment training course, and I was given a tour of the plant and the lockout tagout system. It's basically a big station where everything is located for lockout tagout. And most of my training was given on the spot. It wasn't too much training when I first started. I am OSHA 10 certified, so I knew the general safety precautions, as well as one of the supervisors who showed me around was an MMA grad, and he knew we learned about lockout tagout here. So I didn't get too much training in those areas, but I was very impressed with their upkeep of lockout tagout as well as the hot work and confined space permits. Everything was signed, everything was brought to a supervisor before any maintenance was done, and I was very impressed with it. We also had monthly safety meetings, which I did attend, and we went over safety mishaps and suggestions and how to improve on the mistakes that happened, if any. And during my experience, I was mostly an assistant to the operators and maintenance guys. Oh, actually, I forgot one thing. The PPE. The PPE included that handsome devil right there. There's a hard hat, steel-toe boots, jeans, safety glasses, and ear protection. Gloves weren't required, but you could wear them if you'd like, or depended on what you were working on. So during my experience, I mostly did maintenance, actually. Gonna be honest, this plant didn't really have a good plan for co-op students, so I was basically just assisting them with whatever they needed help with, especially during shutdown. There was a lot of things that needed to be fixed, especially on the boiler side, and there was also a emergency shutdown once that lasted about a week, and some stoker grates needed to be replaced, so I helped with that. I also did maintenance on other things like the cat bulldozers that they had there for the fuel. And a lot of my time was also spent doing cleaning and yard work around the plant, mostly mowing the lawn and weed whacking. Fun. So some things that I learned during my maintenance experience, I helped replace 3 ash reinjectors. I also learned how to remove and clean a pipe strainer that was connected to the main condenser circ water line. And the way you do that, they taught me how to find it. There's 2 different pressure gauges, one before and one after the strainer. And once they're not equal, you know that the strainer's backed up. So I found that very interesting. And whenever I needed help with any of my schoolwork, all the employees were very nice and they were always willing to help me or answer any questions I needed, guide me in the right direction. I also learned in general how a power plant, a biomass power plant, works. Once I traced the main steam and all the other things for the co-op project, it really helped me visualize everything we learned here at MMA. So in conclusion, it was all right. I guess for CO200, I would recommend it. CO300, you're probably not really going to get anything out of it that you haven't learned already. There honestly isn't too much to do there either, because it's a small plant, only around 4 operators, if that's usually 3. So there isn't really too much work to help with, but if you're looking for a basic power plant co-op, I do recommend this for CO200. All right, thank you.
All right, my name is Madeline Martin, and I spent my field experience at the University of Maine in Orono heating plant. So the main purpose of this plant is to generate steam, which is sent throughout the whole entire University of Maine campus for heating purposes. During the winter time, the steam production is about 90,000 to 120,000 pounds per hour of steam, but that drastically drops to about 20,000 to 30,000 pounds per hour during the summer because you don't need as much heat. There's not people on campus. So this plant consists of 4 water tube boilers. 2 of them are number 6 oil, and the other 2 are natural gas. One of them actually used to be, one of the natural gas ones used to be a number 6 oil burner, but it was converted into a natural gas burning boiler. This plant runs all year round. I think I asked them when the last shutdown was, and they couldn't even remember. So it's always running. There's always somebody there. And yeah. So obviously the first day we got there, we were given PPE, and then we spent 3 or 4 days just in safety workshops. Probably the ones that stuck out to me, obviously, are the lockout, tagout, and the confined space training. We were in and out of a lot of confined spaces, so being able to fill out the paperwork and just create a safe confined space was very important. So for my work experience, we mostly were involved with the maintenance technician of the plant, and he had to be involved with everything that happened at all times. So we were always with him doing maintenance, which usually involved us kind of chasing our tail almost, because just it's an old plant, and once you go to fix something, you find another problem wrong, and it was just a lot of playing catch up during the summer season. And during the summer, all of the boilers are shut down at one point for annual maintenance, which means the state inspector would come in. So we would have to go in to each boiler and make sure it was ready for the inspector to come. So I was actually able to be a part of cleaning each boiler, which was cool to see the different kinds of boilers at the plant. We also were involved in the boiler feed water testing and treatment. So we did that Monday, Wednesdays, and Fridays. And that just creates you treat the water so that obviously you create better conditions for the boiler in operation. We also spent a lot of time just repairing valves, all kinds of equipment, making sure it was ready to go. So in conclusion, I thought it was a great first co-op, mostly because I was able to really get involved with all the equipment and machinery. And yeah, thank you.
I am Seth Pellerin, and for my CO200 co-op, I worked at the Penobscot Energy Recovery Company in Orrington, Maine. Penobscot Energy Recovery Company, or PERC, is a waste-to-energy power plant. It operates at 7 megawatts and can operate up to 25 megawatts. It has 2 boilers, each with a steam output of about 133,000 pounds per hour, so in total 266,000 pounds per hour, and the plant operates 24/7, 365 days a year. Safety was a big part of PERC. I had 2 days of safety training. PPE was pretty standard with safety glasses, hard hats, uniforms, steel toe boots. Hearing protection was needed in a few places, mostly in the powerhouse and by the atomizer. Confined space was something that was needed to do very often. Conveyors would need to be cleaned multiple times per week and required confined space permits and sniff tests. Fire safety was also a big aspect at the plant. Fires could break out anywhere with the amount of waste going through the plant. Most were usually pretty minor, but my crew had dealt with two very large fires within 1 week that needed the fire department to come, and it caused the plant to go offline for about a month. My role. So my role at PERC was a bee operator. I had most of the responsibilities of the other bee operators other than fighting fires and driving trucks. I had to do various logs, midnight log and smooth log, and these were checking various gauges and tank levels around the plant at certain times. The midnight logs would be done every night at midnight, and the smooth logs would be done about every 4 hours, 4 to 6 hours. I had to do feeders, which was basically cleaning off the feeders that led the waste into the furnace. And I would also do hourly rounds, checking pieces of equipment like the atomizer or the slaker. So in conclusion, I learned a lot at PERC. I learned how a plant operates, and I learned the process of how to start and stop the turbine. My experience at PERC was very good. It is a waste to energy plant, so it can be pretty gross and you see some kind of nasty stuff, but once you move past that, it's really not that bad. I really enjoyed the people I worked with. All of them were very nice and very willing to help with whatever I needed. They really wanted to help teach us really how to work in the industry. Overall, I think it was a great experience and one that I would definitely recommend to anyone else who's looking for a summer co-op.
So I am Wolfgang Redman, and if being a volunteer in the PET program or volunteer in the Reg isn't weird enough, I worked at a solar company instead of a normal power plant like everybody else did. I worked at the National Renewable Energy Corporation, or NRENCO, to shorten that mouthful of a thing. It's located in Charlotte, North Carolina. The company owns 25 plus different utility-grade solar sites. So our largest site, the Lilly site, is 103 megawatts. The way that a solar farm is measured in output is at peak performance, so like noon, midday, when the sun is full on all the modules and arrays. So that one hit 103 at max output, which is pretty impressive. And it was, the Lilly site is both a ground-mounted and tracking systems. So in the flatter sections of a site, you'll have the tracking systems, which are the ones that track the sun and stuff. They have to be on a relatively flat ground for that. And where there's hilly areas where you can't really track properly, you just kind of put a bunch of ground mounts there to, make up the space. The safety program on a solar site is pretty similar to a normal conventional power plant. You got the work gloves, safety glasses, full jumpsuit for when you're working on electrified stuff. The safety culture at NRENCO is also pretty notable too. The company is really safety forward. They allow the technicians to take breaks whenever they need. They'll pay for coolers for the technicians because South Carolina and North Carolina, it gets pretty hot in the middle of summer there. So they'll work with you, work with the technicians to make sure they're all safe and not going down to the heat or like the systems and whatever. My time spent in NRENCO was split roughly in two phases. The first phase was I got there in the middle of a changeover between the monitoring specialists and the O&M department, the operations and maintenance department. So I kind of just became a underpaid monitoring specialist for the control center. So when I was there, I worked on spreadsheets. I made sure the sites were operating at as much capacity as I could. Just informing the technicians that if, hey, something went wrong. Towards the end of the internship, I was able to work on a site like a normal technician, and that portion involved a lot of moving busted panels and modules and helping put some on the mounts and learning exactly how a site is wired up and stuff, because I really didn't have a clue when I first went there, so I learned a lot about that when I got there. In conclusion, I would really recommend Norinco if anybody is interested in solar or renewable energy, because they are a really good company about it. I learned a lot there, especially since, we don't teach very much solar there, so I learned a lot going in there. Had to relearn a lot of stuff. So, yeah. That's it for me.
Hi, my name is Holly Rena Morning, and I did my CO200 co-op at the Wood County Solar Project, where I worked for ASCO, Burns & McDonald's in Nakusa, Wisconsin. This field is made up of 41 different blocks, where each block had 30 tracker rows and was separated by 3 inverters. And when I was on site, they just finished installing the solar panels, so they're slowly starting to produce power into the grid and the substation. But overall, the solar energy facility should produce 150 megawatts. And when completed, it should positively impact the environment by generating low-cost energy and clean energy to tens of thousands of homes in Wisconsin. For plant safety, we were actually sent to the headquarters in Appleton, Wisconsin for the first week, where we did an online course, and ASCO requires all employees to be CPR certified before going to the on-site. So then after the first week was completed, I then had to watch a safety orientation on site, and we were given PPE where we wore our hard hats, our foam-lined safety glasses for sand dust, and our steel-toe boots, and our high-V safety vests. Every morning we had a safety meeting where the safety site manager would come and discuss what safety, if we had a safety moment that time, and then we would meet up with the project manager on site. And we did lotto training, confined space entry, there was barrier tape usage, spotter training, and hot work permits. And ASCO has also been rewarded twice with 8 straight years with no accidents. From my experience, I was a construction coordinator for the electrical field. And basically what I did is I did claiming for the labor unions. So I did cable pole length for PV connections, wire management, and also I was able to print out labels for the combiner boxes and did PV testing and IVR curve testing, polarity checks, and did some wire management on the different inverters. In conclusion, I would recommend this co-op to another student. I learned a lot of new skills and was able to use my skills from computer apps of power and electrical power. And the president of the company is actually MMA alumni, and he's always looking for new MMA students to join the crew. That's it.
All right, I'm Philip Rosborough, junior in the PET program. Did my co-op at Maine, located in Portland, Maine. Maine is a trash burning plant, produce about 14 megawatts. After we power the waste energy facility and the recycling facility, we produce about 11 megawatts to the grid. 2 mass burn Steinmuller boilers rated at 77,000 pounds an hour each. They produce right around 650 psi steam. Base loading plant typically, but the steam turbine was out for a major outage the entire time I was there, so we did not produce any power. Safety at Maine is a little different than a lot of the other plants. Maine's a nonprofit and municipality owned, so it's a little different than the regular companies that are OSHA guidelines. So first day we watched a half-an-hour training video on plant safety, and then we took a tour of the plant, and that was that. PPEs, hard hat, safety glasses, steel toe boots, long sleeve shirt, long pants, and then hearing protection when required, which is pretty rare because the plant typically runs pretty quiet. Second day of work, I was sent to Concentra in Portland to get a physical. There for about 4 hours waiting, and then physical took about an hour and a half. And that's an annual thing for current employees, just to make sure that you're not inhaling any of the fly ash, because that's pretty bad for you. I was also fitted for a respirator on my second or third day there, just so I had it in case I had to go inside the boiler, the superheater at all for outages. Lockout tagout, I was given a basic training on lockout tagout. It's used for any maintenance, any repairs. A good part of the systems at Maine were locked out because of the turbine outage, so that was interesting to see. And I was also given a lock so that when I was doing any maintenance, I could put a lock on the box so that nothing could be started up if I was working on it. And then job safety analysis, most procedures at the plant already had a JSA written up, so you could go to there's a filing cabinet, and you could go get your JSA, or if it was a new job, you could fill one out. My work experience, I started the summer with maintenance, did a little bit of everything from daily rounds, greasing, helped one of the mechanics with a new piping system. I got to weld, use cutting torches, a ton of preventative maintenance on, anything from the loaders that they use in the tipping hall to, feed water pumps, anything like that. And then the rest of the summer I spent working with operations, mostly the utility operators. That's 2 rounds per shift and water chemistry testing. If you're on day shift, most times they're going to have you do some sort of lockout tagout for maintenance. So day shift is a lot more hectic than nights. And then every shift at Maine, you do have to start up the slaker and shut it down. And just as an operator, you're spending a lot of time watching that, because if the slaker backs up, it makes a huge mess. And if the slurry runs into the storm drains, we have to call the Maine DEP. Another thing as an operator that you're constantly doing is checking on the ash extractors. If those plug up, which I saw multiple times this summer, it's no fun. They get real hot, and it can cause damage to the boilers, so you're constantly checking your ash extractors for any sort of plugs and be in contact with the control room. Because of the reduced loads this summer, so without a turbine, we were unable to run at full load. So we were running at about half load all summer, and we weren't burning enough trash. We ended up having to bypass at landfill, and that was costing the company a ton of money. So we installed this steam silencer that they rented, and basically the purpose of that was just to dump steam so we could run at full capacity and burn. We about doubled our trash throughput. I don't have a picture of it, but we also rented a portable reverse osmosis unit that output about 120 gallons a minute so that we could keep up with the amount of steam that we were, the feed water we were losing. In conclusion, Maine's a great place to work. A lot of MMA guys there. Very helpful. Answered all of my questions. I had a ton. They were flexible with the schedule, and they always encouraged you to learn. They offered multiple times, come in early, stay late, locking out systems. I saw multiple shutdowns this summer, and overall it was a great place to work. Thank you.
Slideshow. Hi everyone, my name is Dean Smita, and this summer I worked at the University of Maine. So for the plant description, we ran 4 boilers throughout the summer. One was natural gas and the other 3 were number 6 oil. With the UMO plant, we were very fortunate enough that everyone there was very calm and straightforward with us, and they took their time. They didn't rush us through anything, and they wanted us to be a part of everything. With the boiler operators and the assistant boiler operators and the maintenance techs, if we were working on valves or if we were doing a pressure test, they would come over and let us know, hey, we're going to start going and doing this. If you have a moment, come over. We'll show you how to do it. Even bringing oil into the plant. When we got deliveries, they showed us how to do that. And then basically the startup and shutdown process. So we always had one boiler always running so that we can produce steam to UMO, because a lot of the pipes that are in the University of Maine are extremely old. And if we actually shut down steam, they're so brittle that some of them might actually break as well. So with that, and at the plant, we would shut down one of the boilers at a time. We would go in, and then we would start cleaning them. The gentleman to my right is also named Dean, and he was an assistant boiler operator, and he helped me quite a bit throughout my time at UMO. He helped me with the starting up a new boiler. So we had these oil guns that we would press in new oil, and it was basically like if you messed up a little bit and you oversaturated the boiler, it was like a dragon breathing fire back at you. You needed to be careful that you didn't get hit with the flames. So we had a fire retardant suit, we had a mask that we wore, and then each time that I was starting up or shutting down, they were right next to me, hands-on, showing me what valve to open and close. And then once we lit it up and it went on, we went over and checked to make sure that the boiler had a good flame coming through, and we continue on with that. With the plant safety, as my former coworker went over, safety was big with UMO. We went over a few days of class, but then each time we had to do a confined space entry, or if we had to go into a boiler, they sat down with us and we filled out the permit that we had to go through, and then also testing of the air. They had us use the devices and made sure that the space that we were about to enter or the job that we were about to work on, we were comfortable with what we were doing. We knew what we were doing, and if at any point in time we had questions, they'd stop us, we'd go over it again, and we'd keep moving forward. With my awesome fire retardant suit, I also had a rubber ducky suit that was completely rubber, and we used that when we entered the boilers. We spent quite a bit of time inside them cleaning through. So we would wash them down with water, getting all the dirt and soot off the water tubes, so that they would be good. So when we restarted the boiler, they would be more efficient. So work experience, we spent the majority of time with the maintenance techs, which was efficient, but then also a little bit of crazy at times, because we would find something wrong. When we opened up like a valve, we'd have to replace it, and then we'd also realize that maybe the pipe that it was connected to as well needed to be replaced, and it was one problem after another because the plant is so old. In conclusion, with my experience here at UMO, I had a great time. I learned a lot. When I first went there, I thought I was going to be going in and nuts and bolts were going to be flying by and alarms would be going off. And that wasn't the case. The plant that I learned about was that these guys were really experienced and they took their time, and through that I got to learn a lot more from the classes that we had, and then seeing it in real life, I learned a lot from it. So I had a great experience, and for anyone who's going into CO200 and wants to possibly work at UMO, I think it would be great. Thank you.
There we go. Good evening. My name is Deacon Trask, and I co-op this summer at SAPI in Skowhegan, Maine. So SAPI had 3 main boilers and 1 auxiliary boiler. The main boilers produce 900 pound steam, and the auxiliary boiler would do 160 pound steam. The auxiliary boiler usually does not run unless they need it during an outage or on a cold startup or situations like those. The first boiler is the recovery boiler, and that does about 750,000 pounds per hour, and it burns heavy black liquor. It's also can be supplemented by number 6 fuel oil. The other 2 boilers are hog fuel boilers, which burn bark, biomass, tire-derived fuel, and waste treatment sludge. Those boilers, they're called Hog 1 and Hog 2. Hog 1 did about an average about 350,000 pounds per hour, and Hog 2 did about 450,000 pounds per hour. The steam is sent to 2 General Electric turbine generators. Combined, they'll do about 110 megawatts max. Typically, they were set to make about 70 megawatts, and they would buy the rest from the grid, and they would adjust the amount of power they made depending on the price of the power from the grid. Both turbines have a 60 and a 160 pound steam extraction, which that's used for the paper making processes and some other systems within the power plant itself. The safety program at SAPI, when you first arrive on site, basically about a full day worth of, it's like a big safety meeting with they try to time it up so the new hires and co-ops all showed up the same date, so you'd have one meeting. Once you do that, you go on a site safety tour where they show you around and tell you where not to stand and where you can and cannot go. They also have different PPE requirements depending on which area you go into. The most interesting for that was we actually had to carry around personal escape respirators because there was chlorine dioxide used in the pulping, and if that leaks, I guess you need to put the respirator on to escape. It was also interesting when about halfway through my co-op, they actually reached 2.5 million worked hours without a lost time injury, and we actually continued that through the rest of my co-op. My work experience, I worked with the engineering and operations. It's sort of a link between the two. So anything the engineers wanted to do with the operations, I would go do that for them. Many projects required me to work with other companies as well, outside of SAPI, to either set up projects or meetings, give them site tours of the equipment. There's also probably the most interesting experience I had was when I showed up, the turbine generator number 1 was in a major overhaul. So basically when I showed up, the casings were apart and the rotor was sitting in place. They took the rotor out. I sent that to Texas to get machined, and I was able to watch them do all the work to it. And eventually, at the end, once it's all put back together, I basically helped with the initial restart. In conclusion, I would recommend SAPI for anyone looking for a co-op or even a job. It's a great place to be. Everyone there will basically help you if you need anything or any question you have. Everyone's willing to help. SAPI actually had quite a large amount of co-ops this year while I was there, mostly from Maine. There's, I think, 2 of us from MMA, and I would love to see more next year. Thank you.
Hello, my name is Colby Van Decker. I spent my CO200 co-op at the Androscoggin Mill in Maine. It is owned and operated by Pixel Specialty Solutions, a company out of Pennsylvania. So plant description. We have a cogeneration plant and a power plant. It runs as a combined cycle plant. In the cogen plant, there are 3 combustion turbines with HRSG units. These are dual fuel combustion turbines. They can burn natural gas or number 2 fuel oil. During the time that I was at the plant, we only burned natural gas. At least 1 unit is running at all times. It has to supply steam for the paper making process, which is a 24/7 process. And then also supplying steam for the steam turbine. During normal operation, we were running around 30 megawatts of power. We would either add megawatts or add another combustion turbine to increase the megawatt output according to what the grid was calling for. Each HRSG produced 900-pound, 160-pound, and 60-pound steam. The 900-pound steam was 450,000 pounds per hour for if all 3 are running. The 160-pound steam was 120,000 pounds per hour, and the 60-pound, 50,000 pounds per hour. And the steam turbine, maximum megawatt output per turbine was 26 megawatts, and we only had 1 steam turbine running at all times. Sorry. Safety program. So we started our first week at the mill in a classroom setting doing safety presentations with the safety director. We went through all the typical things, PPE, lockout, tagout, hazard training. There's a lot of hazards in an old paper mill, including asbestos, lead paint, There's still, even without the pulp mill running, there was still H2S to be concerned about. So we had to wear H2S monitors on the back of our helmets at all times. As far as PPE, we were wearing hard hats, steel toe boots, safety glasses, hearing protection when needed, and gloves if we needed to perform any tasks. As far as operational procedures, the first week actually on the job, we were given a packet, on-the-job training packet, and we went through all the procedures of a field operator. So work experiences, I had the job of a field operator in the power plant. So we completed steam turbine, air compressor rounds, completed water testing on various condensate sources and demineralized water. And I was able to experience a couple startups and shutdowns. One was intentional because we were replacing a steam stop valve. The second was unintentional, and that is why that turbine is taken apart. The generator became motorized and was spinning for 45 minutes motorized, which was not good. So I got to experience that, which was cool. Not good for the plant, though. So in conclusion, I had a great experience. Everyone was very helpful there. Everyone was very nice. Would I do it again? Yes. Unfortunately, heard the news yesterday, the plant is going to shut down in the first quarter of next year. So that is definitely unfortunate. It's too bad for the town. So yeah, thank you very much.
All right. Hello, I'm Thomas Van Dynes, and this summer for CO200, I worked for Vistra at their Blackstone, Massachusetts plant, Blackstone Energy. So Blackstone Energy is a 500 megawatt combined cycle plant, consists of 2 units. Each runs a GT24 gas turbine, and the HRSG's capable of 583,000 pounds per hour of HP steam, 476 of IP steam, and 300,000 of LP. They were on a single shaft alignment, which is a very European design from my understanding. A lot about the plant was very European in nature. So for kind of safety overall at the plant, the big thing when I showed up was I had an orientation video and then was shown around the plant, and that was kind of the extent of my safety training. But the big thing for the plant was voluntary protection program. First couple of weeks, that was kind of the big deal. OSHA coming during my 3rd week. And we did end up getting that VPP star status, which for those of you who don't know, to get it, they make sure that you have implemented effective safety measures and that you are below kind of the average workplace injuries. And on top of that, we would have regular weekly meetings as a company as a whole, Vistra as a whole, go over recent incidents that would have happened at the plant. Anything from, there was a HRSG explosion one time down in Texas at one of their plants to near misses, near lotto misses. And as of July 27th, they were at about 6,800 days since the last lost time incident, and I'm sure that is continuing to grow. So my overall work experience, I followed either a day-based operator or a shift-based operator around and kind of grew my tasks, starting with rounds, which could include checking the gearbox oil levels in the air-cooled condenser, going into the gas turbine enclosure, making sure everything was okay in there. Weekly and monthly PMs, water chemistry,
pre-coats, especially during startups. And kind of an interesting experience, we hired a couple new operators towards the end, so I was able to really test my knowledge of the plant, and the control room operator that week definitely made sure that the new guy picked my brain a lot. So it really was interesting seeing kind of the progression where you start to where you end in that instance. Overall, it was a great experience. Guys there really nice, with a lot of experience. Definitely a lot of older gentlemen work there, but they have a lot of experience. Maritime grads, a lot of Navy nukes. Majority of them are retired Navy nukes, and the plant manager there was a MMA grad, so he was definitely happy to have another MMA student around. But yeah, definitely a great environment. Was able to put what I learned and apply it, and also learn about new systems, especially the gas turbine, which was kind of I focused on a lot. Yeah, thank you.
Good evening, ladies and gentlemen. My name is Xavier Vuyu, and this summer I worked at the Linden Cogen plant in Linden, New Jersey. So the cogen plant generates 972 megawatts, and it has 6 boilers and 3 steam turbines. 5 of the boilers are connected to a grid to sell power, and the 6th boiler is used to power the plant. The boilers run off of natural gas and uses butane as an alternative source, but as I was leaving, they were doing a project where they were trying to replace the butane with a hydrogen fuel blend, and that's going to reduce the CO2 emissions by 10%. The plant has 3 stakeholders: JERA Corporation, Oak Tree Capital Management, and Aris Management. JERA holds 50% ownership, and the other 2 hold 25 each. And with JERA being the larger shareholder, they are in charge of operation and management. And like every other JERA owned site, they hired a third-party company named Mace Corporation, and that's who I worked for this summer. Training lasts about 2 weeks. I did OSHA training online for the majority of it, and I did training on things like PPE wear and confined space entries, hot work permit, lockout, tagout procedures, and stuff like that. My everyday PPE wear, I wore hard hat, safety glasses, steel-toe shoes. If I was working in the turbine hall, you'd wear earplugs because it's very loud. And I was cycled through 3 different departments: control room operations, maintenance shop, EI&C shop. I spent 6 weeks in operations. The first 2, like I said, training. And then I spent the other 4 weeks shadowing control room operators, doing boiler chemistry, doing rounds and taking readings on the east and west side of the plant, performing lockout, tagout procedures with the APOs, and that type of stuff. And then I spent 2 weeks in the maintenance department, getting my hands dirty, repairing and replacing oil pumps, replacing air filters and greasing bearings. And then I spent 3 weeks in the EIC shop where I learned how to calibrate gauges. I learned how to wire fans to go different speeds, and I learned how to check for hot spots on breakers and stuff like that, and report that to the supervisor. Would I recommend this site? Yes, I would. It's a very friendly and welcoming learning environment. Everybody there is willing to help pitch in and make sure you're learning at all times. I learned that the way to their heart is pizza. They really love pizza. And but overall, I met some really good people this summer, and I'm going to keep those connections. Thank you.
Hello, my name is Seamus Winning. I work at Wind Waste Innovations in Concord, New Hampshire for my CO200 project. We were a base load power plant that output 14 megawatts. It was a mass burn trash plant, and we took about 575 tons per day of municipal solid waste in to burn. And we had 2 B&W boilers that each put out 69,800 pounds per hour of steam to a dresser ran 16-stage turbine generator. For the safety program, we did 2 to 3 days of online training called Win Academy that went over all lockout, tagout, confined space entry, hot work permits, all that stuff. After we got done with that, they took us and gave us PPE and excuse me. We had hard hats, steel-toe boots that they purchased for us, safety glasses. They gave us all uniforms because the ash is hazardous material, so you can't bring that home with you. We also had our personal single-point lockout locks, stuff like that. And then there was JHAs that they had for every single job that they had there. You could print them off anytime from any computer in the plant. We also did JSBs, job safety briefings, before any non-routine work, and that ensured that everyone was on the same page when the job started. I also got to be part of a boiler lockout to do blasting. So we had to fill out all the permits and then put the locks on and then verify all the locks, and that was pretty cool to see. My work experience was fairly limited. We did a lot of cleaning and just maintenance. We also got to operate I also got to operate the lime slakers for the SDA towers to take care of HCl and SO2 emissions. There was also the carbon feed pumps that I got to calibrate every day, and yeah, we did that. And then MRS, the metal recovery system, we had a conveyor belt, rubber conveyor belt that would tear, and all of the ash would end up on the conveyor to get dumped into trailers, and when the belt tore, it would dump the ash all over the ground, and we would have to shovel that up every day for like 3 or 4 hours a day. In conclusion, would I do it again? Maybe, if they offered me a slightly different position. And would I recommend it to other people? If it's the last resort. Thank you.
That was our last presentation. Thank you all so much for coming. I do encourage you, if you have any questions, to get together and ask those individually to those who presented tonight. Thank you very much.